We said that in a set, order doesn't matter, and we also said that no duplicates are allowed. Now let's define something similar to a set, but a case where order does matter and duplicates are allowed. And this is called a tuple. And we use the parentheses notation to indicate a tuple. And remember, for a set we had the curly bracket notation. So in the slide here we have shown two tuples that are valid tuples, open bracket A comma B and open bracket A comma A, noting that in the second case we have the element A twice. Tuples, the simplest tuple is a two-tuple, also called a pair or an ordered pair, and an n-tuple is a tuple with n elements. The number of elements in a tuple is also considered to be fixed. We'll now move on to a very important concept, and that is that of the product of sets, also called the Cartesian product of sets. Let's consider the set X with elements A and B and the set Y with elements C and D. Now what is the product X times Y? The Cartesian product of sets is a new set of tuples of ordered pairs where in each pair we have one element of each set. And we have all the possible combinations of an element of the first set with an element of the second set. In order to get the Cartesian product, we can write a table where we put in the first column the elements of the first set, in the first row the elements of the other set, and that allows us to make all the possible combinations in elements of the table. And we see here, since each set had two elements in it, we have a result set of 4 ordered pairs. Another important set concept is that of cardinality. The cardinality of a set is a measure of the number of elements that it contains, and we use the vertical bracket notation. So if we see a set X surrounded by vertical brackets, we are talking about the number of elements in X. For the Cartesian product of sets, we have that the cardinality of the product equals the product of the cardinalities. So we saw in the last example of the Cartesian product, we had two sets with two elements. Each of those sets had a cardinality of 2, and the cardinality of the result set of ordered pairs was 4. And that equals 2 times 2. So we saw the definition of the Cartesian product of two sets. What if we want to multiply 3 or more sets? So the idea is really the same. We do the same thing, but we must do one of the products first, and then we end up with a set of ordered pairs for that product, multiply that out to the next set. So we can take the same approach. In this case we have the sets x, y, and z. We want to calculate the Cartesian product x times y, then times z. And let's take the Boolean domain as our set. So x, y, and z are each the Boolean domain. So let's say we had a result already of x times y. We put the result of that in our column. We make a table just like we did before, but what we have now, our set on the left is actually the product x times y, which is the set of 4 ordered pairs like we saw before, and in the top row we have the elements in z, and we multiply things out just like we did before. The definition has not changed. What we get now is another set of ordered pairs in which the first element is an ordered pair. So we have a set of nested ordered pairs. And again, the cardinality of this result is the same as the multiplication of the individual cardinalities of the sets each, which were 2 each. So the cardinality of the result here is 2 times 2 times 2. There are 8 elements in the result. Let's quickly review which concepts we covered in this session. So we talked about common sets. We saw that the Boolean domain was a subset of the natural numbers, and that is in turn a subset of the whole numbers, in turn a subset of the rational numbers, which is in turn a subset of the real numbers. And we saw mathematical notation, including the symbol for there exists, the symbol for all, and set builder notation, curly brackets with elements x, vertical bar, after which follows some condition for building the set. We discussed universal set and complement, essentially set negation, denoted by the exponent c, and we discussed tuples and the set Cartesian product, as well as cardinality of sets and the cardinality of the Cartesian product. Thank you for watching.